Okay, today's lesson is called factoring. Factoring is when you break a number down into a number of things multiplied together. When you say 10 is 2 times 5, you have factored the 10. When you say 100 is 2 times 50, you are factoring the number. Technically, you could always say 100 is 100 times 1, but we're going to say that that doesn't count as actually breaking the number down. That's just repeating it, so we're not going to allow the number 1 to be used. Okay, the things that are multiplied together are called factors. They're also called divisors because the original number can always be evenly divided by any of them. If a number can't be broken down any further without using the number 1, it's called a prime number. And technically, this is a very technical detail, but to break the number 1 down, the only way you can do that is 1 times 1. That's using ones, so the number 1 is not going to be considered a prime number. I talk about this because the fundamental theorem of arithmetic says that the most important thing in all of arithmetic is that every number can be broken down into prime numbers. Not just broken down into prime numbers, but broken down into prime numbers in only one way. In other words, it's almost like a fingerprint. Every number has a particularly unique listing of prime numbers. So let's do some examples. Let's say we take the number 60. 60, we can break it, I don't know how you want to do it. You want to do 6 times 10? That's a reasonable way to do that. And these numbers can be broken down further. 6 is 2 times 3, and 10 is 2 times 5. However, it can't be broken down any further. So 60 is two twos, a 3, and a 5. Now we could rearrange it. We could have said that 60 was 2 times 30. And then we could have said that the 2 is a prime number, but the 30 we could have said was 10 times 3, and the 10 can be broken down into 2 times 5. And so we get a different order. Here on the right we have the 2 twos together, on the left we don't, but it's still 2 twos, a 3, and a 5. That is like the fingerprint of the number 60. Some people do this with factor trees. 60 is 6 times 10, and the 6 is 2 times 3, and the 10 is 2 times 5. And once something has branched off, you don't really consider it anymore. You get the 2, the 3, the 2, the 5. That is the prime factorization. Another method is called the factor cake. You divide by 2 and you get 30. You divide by 3 and you get 10. You divide by 2 and you get 5. And then here are your factors. Very, very exciting. One might ask, why are we doing everything with multiplication? I like addition better. I find addition so much easier. Well, you see, the number 10 is 2 times 5. That is the only way you can multiply natural numbers to get a 10 without using a 1. I mean, you could say 5 times 2 or 2 times 5, but that's just reordering. If you wanted to add, you could say 10 was 5 plus 5. You could say 5 was 3 plus 7. You could say it was 2 plus 1 plus 3 plus 4. There's a whole lot of ways you can add to make a number, but there's only one way to multiply prime numbers to make a number, and that is very, very exciting. I call them divisors. The number 60, let's say, what did we say? 60 was 2 times 3 times 2 times 5. And ultimately, I would love it if you could start doing this in your head, to not have to do a factor tree every time. I mean, you work your way up to it. The numbers that you would actually need to factor in your life are rather few. 60 is a bit on the high end, but I want you to start trying to do as much of this in your head as you can. Anyway, if you take some, none, or all of these primes, you will give you a divisor. Well, what could we take? We could just take the 2. What does that mean? 2 divides 60. 2 is we would say 2 is a divisor. Or we can flip it around. We could say 60 is a multiple. What do we have to multiply 2 by to get 60? The rest of this stuff. 2 times, what is that? 6 times 5, 2 times 30 is 60. 2 divides 60. What else? We could have just taken a 3. 3 divides 60. 3 is a divisor. Well, if we took this 2, we're going to get the same thing. We could have picked just the 5. 5 divides 60. We could have picked 2 of these things. 2 times 3 is 6. 6 evenly divides 60. Or we could have taken, let's see, 2 and a 3, a 2 and a 2. 2 times 2 is 4. 4 evenly divides 60. 2 times 2, what do we have to multiply 4 by to get 60? A 3 and a 5, which is 15. 4 times 15 is 60. What other ways can we take 2 of them? We could take 2 2s, a 2 and a 3. We could take a 2 and a 5. 2 times 5 is 10. We could have 3 times 5 is 15 is a divisor. Let's see, 2 2s, a 2 and a 3, a 2 and a 5, a 3 and a 5. We could also, is that the only way of taking 2 of them? I think that is. Take 3 of them. We could take the first 3. 2 times 3 is 6 times 2. 12 is a divisor. We could have taken, let's see, that's everything but the 5, everything but one of the 2s. 6 times 5 is 30. We could have taken, let's see, that's everything but the 5, everything but the 2, everything but the 3 is what? 2 times 2 is 4, times 5 is 20. Evenly divides 60. And I say some, none, or all. If we take all of them, we would say 60 evenly divides 60. That's not so exciting. And we also say none. And here is another one of those cases of nothing. Right now we're talking about what? We're not talking adding and subtracting. We're talking multiplying, dividing. And what is none of them? None of them is 1. None of these, tell you, this confuses a lot of, none of these is 1. So what have we decided? We've decided that 1 evenly divides 60. 60 can be divided by 1. 1, 2, 3, 5, 6, 4, 10, 15, 12, 30, 60, and 20 all evenly divide the number 60.